This solar power plant was recently built for almost $300 million in one of the deserts of China. This large mirror and a large number of these mirrors direct solar radiation into this bowl, which will now be shown closer. You see how some liquid absorbs that solar radiation from the mirrors, and therefore it heats up to almost 600 degrees Celsius. I think you have already guessed that this thermal energy will be converted into electricity using turbines, but not immediately, but after the next important stage. This liquid is this salt, sodium nitrate, and the high temperature makes the salt liquid, and this hot liquid goes into one of these huge tanks, and then the liquid salt produces steam which powers those turbines, and the Chinese show this work scheme. This is a constant circulation of the liquid salt during solar hours, where this is the bowl, and this is the movement of the hot salt into the first tank. Here we see the transfer of the thermal energy to this turbine, the movement of the liquid salt at a lower temperature to the second tank, and its return to the bowl, where it is heated again by the solar radiation. During a sunny day, this tank accumulates several thousand tons of the hot salt, which in this way provides the thermal energy to the turbine to produce electricity for 9 hours at night, and this is a big advantage over solar panels, which only work during the sun. Of course, the Chinese are not the inventors of this type of power plant, and this is an example when a European invention became Chinese. It was all started 40 years ago by Israelis, who placed this fixed mirror on the wall and a large number of these mirrors on the ground. The ground mirrors reflect solar radiation onto the fixed mirror, which reflects the radiation onto this receiver. After that, these studies were continued by Arabs, and now I show their mirrors, which should rotate according to the movements of the sun across the sky. Those mirrors are located around this fixed mirror, which reflects the radiation into this receiver with 4 tons of this salt. After that, 10 years ago, Europeans built this solar plant, where this large number of mirrors reflect solar radiation onto these fixed mirrors, which direct the radiation into this tank with sand at temperatures up to 1000 degrees Celsius. Many of you have already noticed that this Chinese solar power plant is a variation of this old European invention, where we also use a large number of mirrors. They must constantly rotate in accordance with the movement of the sun across the sky to direct solar radiation to the top of the tower. But if we install this big mirror, we get the Chinese power plant, and it does not kill birds the way it does near the top of the solar towers. Let's go to the website of this reputable organization and look at the data about the Chinese solar power plant. Here we see an estimate of the cost of its electricity, which is noticeably higher than the cost of electricity from thermal and nuclear power plants. In addition, it is more expensive than the electricity of these relatives, and the main reason for the deterioration in profitability is the loss of about 10% of the radiation on this additional mirror. Nevertheless, these solar structures may be interesting for producing not electricity but thermal energy for metallurgy or the chemical industry, for example similar to this American project where these mirrors aim to heat iron ore or the raw material for cement production. But their production equipment must be located high above the ground, while the Chinese version is located on the ground, and it is important to note that the cost of this thermal energy is about 3 cents per kilowatt-hour, which is cheaper than the cost of heat from natural gas.